Okay, so good afternoon, and thank you for joining us today. I am Alba Marrero, and I lead the aerospace topics related at Hello Tomorrow. So it's a pleasure to be here moderating this session about what may well be the next industrial revolution, one that is bound to happen not only on Earth, but in orbit too. So today I have three excellent panelists with me that I will let them self-introduce. So maybe, David, you can start.
Sure. First of all, thanks for having me be here. It's really a pleasure. So my name is David Dana, and I'm French, based in Luxembourg, actually. Over the last 15 years, I was working for the European Investment Fund, heading the team investing into deep tech VC funds across Europe. And I've moved now to the other side of the table, hopefully the brighter side, as I joined Expansion Ventures as a partner a couple of weeks ago. Expansion Venture being a French-based fund investing into sustainable aerospace and defense startups.
Wow. So, yeah, maybe Nicolas, you want to continue?
Well, hello. Thank you so much for having me. I'm Nicolas Gaume from Space Cargo Unlimited. One of these entrepreneurs that is blessed to have Expansion as an investor. We are based in Luxembourg, in Bordeaux, and in Torino, and we are building a spacecraft. We're actually building the first space factory for Earth to enable a variety of commercial and institutional companies to build in space high-value product for Earth that they couldn't make otherwise, or would be very difficult to make on Earth.
Wow, again. And maybe finally, Hendrik, you can go.
Yeah, thank you for inviting me. My name is Hendrik Brandis. I'm German. I'm a co-founder and partner of Earlybird Ventures. Started that 28 years back, I must admit. Embarrassing long time.
You were 10.
Thank you, yes, hardly. No, I'm an aerospace engineer by training and spent my first professional career with 3 years at Airbus, then some time with McKinsey before I got to Earlybird.
Well, thank you, all of you. So I will start with a bit of context so we know what we're going to talk about. And also don't forget that there will be a QR code and you can submit all your questions and we will cover them at the end of the session. So now, for many people, space might still like a distant concept. Fascinating, but remote and far away from our daily routines, problems, and challenges. However, this might not be the case. The reality is that aerospace advancements have already radically transformed the way we live, work, and connect with each other. Aerospace technologies are so embedded in our daily lives that we can often take them for granted. Think back of the mid-50s, where the first satellite technologies were being developed. Who could imagine the change they would bring, right? And it took almost a decade for commercial applications to emerge, but when they did, they fundamentally changed global communication, navigation, networking too, but broadcasting. So the very foundations of the world that is so digital and interconnected, the interconnected world that we live today, find their roots in space. Today we are witnessing another major leap, this time in Earth observation. Satellites are again revolutionizing industries across the board. They monitor climate change, plastic in the ocean, biodiversity. They optimize agriculture and track supply chains, and they even provide real-time intelligence for disaster response. So that doesn't sound so far away from our reality, right? By the way, some of the innovators working in this revolution are today at the Global Summit with us, so don't miss the opportunity to connect with them. But all of this is in the past and in the present, but what about the future? What comes next? So we are at the dawn of a new era, one where space ceases to be a passive industrial actor to become an active one. An era where space will not only be a place where we observe from, but a place where we build, manufacture, and innovate in ways that are impossible on Earth. Sounds a bit like science fiction, right? But microgravity advancements are already visible in a lot of different fields: semiconductors, stronger fibers, drug development. So yeah, our grandparents used to navigate roads and cities with paper maps, and we just have to locate a blue dot on our phone screen. And similarly, our grandchildren might one day benefit from a medical treatment developed in space, or they might even own a device that has semiconductors developed and manufactured under microgravity. So this is the future that we are here to discuss today. So let's start. So my first question for the three of you is, what advancements have you seen in the recent years, and how do you envision space-based manufacturing transforming traditional industries on Earth? So who wants to start?
Why don't I jump in? Well, it's fascinating because for decades on the International Space Station, on other pressurized space cargo operating in space, there have been thousands of research projects that have been conducted. And they have shown the opportunities that you described in microgravity manufacturing. There's a number of other parameters, including a higher level of radiation, parameters that are impossible to recreate on Earth. You can extract yourself out of gravity. So for those of you who do not know what the environment is, imagine you're producing an alloy. If you want to merge two materials, the heavier one goes down because of gravity on Earth, the lighter one goes up. You do not have a perfect alloy. If you do the same thing in space, in microgravity, you're going to have a much stronger alloy. In fact, you can also do alloys you wouldn't be able to do on Earth, like bulk metallic glass. But it's very fascinating because there are other parameters, like no microgravity means no convection. So you can crystallize some materials, and you can do, for instance, optical fiber that is extremely performing with microgravity. You can, of course, use also the vacuum, absolute zero, for some semiconductor development. Most likely tomorrow, quantum computing could leverage the space environment. And where it's most exciting even is pharmaceutical opportunity, because stem cells grow much faster in space. We actually, Space Cargo Limited, operating a spacecraft that is starting operating this year. We have about 80 engaged clients. We have a spacecraft that can accommodate about 7 clients. We produce in space for Earth. And among our customers, we have a lot of life science, where we have a company that is growing organoids. So they're going to grow organs in space because of the environment and bring back to Earth. One is willing to be able to do cornea to help people with visually impaired to heal. There's another one that's working on skin, to grow the skin of burned people and be able to provide them solutions. So all these very, very amazing scenarios we touched are really unique. And so as a company, being able to empower these companies in Europe and around the world to have access to space. Because I'll finish there, what is most exciting is really a similar kind of moment that we were in the 90s for the older part of the audience, I don't know, but for us, where we had something that was very much government-owned. At the time, telecom infrastructure became more open to public-private partnership, and you started to have price of infrastructure going down, replaced by commercial usage and commercial traction. And I think that's what is very exciting about space, even though it is a cultural challenge, that there are more public-private partnership, and you can bring infrastructure such as the one we're developing for commercial benefits. So super exciting times.
I mean, to complement what you're saying, I think the potential application for space manufacturing are almost infinite. We have heard a couple of examples, and we can probably go on for the next 30 minutes adding examples on top of it, and this is only scratching the surface. I think applications is unlimitless. You were asking what has changed over the years recently, and I think what has really changed is that space has become more accessible because costs have come down so much. This is also one of the reasons why satellites, I mean, used to be 100 million apiece, have come down to a couple of 10K, and now all of a sudden we can afford low orbit constellations with thousands, even 10,000s of satellites, which were unpayable, unaffordable in the past. Same thing if you think about per kilo prices for orbit transport. I well remember when the price per kilo bringing into orbit were at $100,000. Now we can come down as low as $2,000 a kilo. That is a totally different thing now, and all of a sudden mass production, mass transport, logistical needs become affordable and space is accessible for different application usage, including manufacturing.
Yeah, I think adding an additional perspective as a LP and VC and now GP, without going into too much technicalities, which I'm not qualified for, and I'm lucky to count on my great partners to do that. I recall when we started discussing about space financing at the European Investment Fund many years ago, everyone started laughing, saying, yeah, but financing rockets and satellites is not adequate for a VC model. But you just have concrete examples that it's much, much bigger than that, and you have so many applications possible. Just looking at the fields which are covered, and now looking at a very concrete application, just imagine that you do not get any data on your mobile phone.
Exactly.
So what happens? How can you survive now? I'm sure we could, but still our lives will change. So starting with data collection to manufacturing, there's a whole range of applications possible, which now become indeed more accessible from a financial standpoint, and also the geopolitical situation makes it not a battlefield, I would say, but something where Europe specifically has a role to play and needs to make sure that we lead the innovation wave to make sure that we remain independent and we have the capacities to do so. We were talking about manufacturing or anything else that we want to do with space or from space, and for that we need to launch. And we have very limited, if any, launching capacities in Europe. So the whole ecosystem needs to be looked at carefully and supported at the same time that looking for sure at financial objectives.
Yeah, actually that's... Oh, sorry, you wanted to...
No, please go ahead.
Yeah.
I just wanted to comment, I think you're making a good point. The true bottleneck for space manufacturing, in my perception, is space infrastructure. Providing the logistical capacities to bring stuff up and down. It's complicated. It's different than just bringing it to the next door.
That's what we do, huh? So you should.
Yeah, but this is one of the key challenges, and that providing capacities at scale is an issue. And I mean, if we're just considering, I think the prediction is currently we're launching something. Let me say that over 30 years, the global world launched between 50 and 150 satellites per annum. Last year, we've been at 2,500. The prediction for 2030 is 10,000 maybe. If you then know that at a single rocket launch, you may be able at most to drop some 20 satellites, because of the second stage has only fuel to fly to several orbits, you divide that by 20 and you do not have 20 in each and every launch, you probably need something like 600,000, 700,000 launches annually in order to meet that demand. I mean, Soyuz is out for the time being. There is no significant activity in other parts of the world than in the US. You have obviously Falcon 9. How many launches are they doing? 30, 40?
No, one every other 2-3 days.
Let it be 70. Long way to go to come to the 1,000. And if you talk about Europe, where probably one hand is enough to count the launches here, that is the issue. And we have to become independent. It doesn't really matter if we have the technology up there if we cannot bring stuff up. That needs to be solved. And so at scale, we need basically every day a rocket launch in order to meet the demand and to really yield the opportunities which we're going to have in space. And, regions who are not going to use these opportunities will fall behind and will become dependent on other regions, and that is scary.
That is scary in every industry, actually. But so now you were starting to mention the challenges, infrastructure being the main one for sure. But what are the opportunities, let's say, in the next 10 years in this area for investors, but also for pioneers that are starting to kind of provide these services, and also for the potential clients and users of these in-space manufacturing services?
Yeah, okay, I can start. I think as we are discussing about this topic, manufacturing in space in microgravity environment is something which can have a huge impact on so many different sectors, starting with any kind of goods, but also anything related to life sciences, medication. We are seeing more and more companies active in the space pharma sector. So there are many applications possible. The main concern would be potentially then to make sure that we are in a situation and in capacity to send automated labs ready to be operated either from Earth or automatically in space to secure what is produced and to bring it back.
I agree with you, David. That's what Space Cargo Limited is doing. And Space Cargo Limited is flying this first vehicle called Bentabox, returning it from space to Earth. We do this with a great partner named Atmos, providing the re-entry technology. And we rely on SpaceX today to launch. And that's definitely, I could not echo more the need for us to have an ability to launch. Now, I would say there's a number of great initiatives in France, in Germany, in Italy, in Spain, and in the rest of Europe. So we can hope that this issue will be addressed in the coming years. I think it's interesting because when you shift, and it's similar fashion going back to the analogy I used of the internet and then mobiles in the 90s and the 2000s, is that when you move from an infrastructure that is led by government institution that create a foundation that is obviously absolutely a necessity legacy. I mean, this could not thrive without the leadership of the European Space Agency, the French Space Agency, the German Space Agency, the Italian, and all the governments. But as we grow, it's changed the shift from a technical-driven, technical-obsessed, to a service-driven, to a outcome-driven. And I think that the most exciting change is going to be cultural. Today, we have a lot of space organization guessing what could be done, and they have guessed wrong in the past. I mean, the topic of in-space manufacturing have been around for many years, and some believe it will never happen because it never materialized. The truth is it did not materialize because the launch costs were too expensive, the infrastructure that allowed in-space manufacturing was not available, and I think it's going to change very much, which means it's going to change the way. Today, among the 50 customers we've engaged with Space Cargo Unlimited, most are commercial company, startup, or scale-up. We don't have the huge European, primarily, stakeholders in pharma, in new materials, in electronics. I mean, there's no Bayer, there's no Sanofi, there's no L'Oréal doing development, and actually they have a lot of reason to do it. So as we shift to a more service-driven, more obsession for outcomes, as the price gets more stabilized and the entry of cost goes down, I think that a lot of these companies will use this. And we can go from a market that is arguably today around hundreds of millions of euros of purchase to tens of billions.
I mean, you were asking where are the opportunities. I would rather ask where no opportunities. I mean, there's so many opportunities in space that I'm just blown away. We were talking about the launches. I mean, people will say a rocket is a rocket. It's not a rocket. You have different weight classes, payload. You have small mini launchers for a ton, which can efficiently distribute microcubes. Then you need, the SpaceX, the Falcon 9 class, 20 tons. It's like on the truck on the road. Yeah, you would never ever deliver 2 books with a 36-ton truck. Yeah, it's not efficient. So you do not, and a Starship is useless for lower orbit microsats. On the other hand side, if you go and build significant factories in space, yeah, be it photovoltaic power plants or whatever you have in mind, you need Starship. You cannot do it with a micro launcher. Yeah, because it's like with a small Polo in building, a new factory. It doesn't work. So you have the different weight classes, and you have to have the full range in order to be in the position to utilize space opportunities. We are happy in Europe if we have even one launcher, not even talking about the weight class in Europe. Yeah, we have Ariane 6, which is actually outdated, old technology, and that's it, and nothing else. We are not competitive. Huge opportunity. All the different launchers. Then it comes in the satellite manufacturing. This is handmade, specific. Each individual satellite way too expensive. We have to industrialize manufacturing of satellites. We're going to manufacture 10,000s of satellites every year, and it doesn't make sense to do them individually handmade. They have to standardize. You have to have first-tier component manufacturing for standard components of satellites, that you do not have to do the full value creation each and every satellite. Doesn't make sense. And then we come all to the application and services, manufacturing, what have you. It is hard to not see opportunities there.
And at the same time, having all those opportunities and being so early, I would say, in the European space development, we have the opportunity also to position ourselves and to decide how we want to make it happen, because we have some good examples of things which worked and things which didn't work that well. So now it's up to us, talking about everyone, all the stakeholders in this system, to work together and decide how we want to make it happen. Because as you said, sometimes we need nano satellites, sometimes much bigger ones, but we need to make sure that we have the capacity to produce them, and also then to send them to space and to collect the data and the whole channel.
Come back. So, well, one last question from my side before we jump into the audience questions, that there are several. So, if you could choose one thing to see happening in the upcoming years in this area, what would it be?
I'm going to repeat what you said. As a spacecraft manufacturing company and an operator of spacecraft, I depend on launch solutions. So I do want Europe to be able to launch and make it a strong foothold for commercial opportunities, because we have this autonomy of launch.
I agree with you, Nicolas. I think if you dig for gold, you start with the shovels. And the rockets are our shovels. We have to build working launchers. And that will bring launch costs down, and that will be the facilitation of the entire space industry. If we not manage to build cost-efficient launchers for all the weight classes, we are in a challenging position.
And reusable, hopefully.
Ideally. But also, importantly enough, we need to have a couple of operators, not only one single entity. So there are already a number of private initiatives, some of them being heavily funded, some a bit less, at different stage of advancement. We need to have a couple of options, and not only to be dependent on a single counterpart, which for whatever reason will also, of course, send to space non-European products, satellites, rockets, whatever. Yeah. So we need to make sure that we are the continent, and I insist on that, not only because I've been for 15 years in a European institution, but because I've seen over the years that there's not enough unification of those objectives. There are common goals, but each and every country tries to do its own thing, whereas if we join forces, we'll have much more opportunities.
Yes, let's join forces, please. Okay, so let's move with the questions from the audience. First one, in which ways do you think interstellar manufacturing could contribute to sustainability?
Well, I think that there's a number of things that answer this question. Once we have literally free energy in space. I mean, a solar panel is about 20% performance on Earth. It's doubling, at least in space. There's obviously a lot of things that also can be done when you want to create vacuum, when you want to create a number of things in industrial processes. I thought about electronics. So there's the cost of exiting the atmosphere, which has a carbon footprint, obviously. You mentioned briefly sustainability. I think it's a strong obsession that a lot of these new rocket companies are doing to make more sustainable engines that are really hydrogen-based and make sure we have much more reusability. So if you find the right balance, we're having the right sustainably conscious, let's say, solutions, there's a lot of things you can do with cheaper energy, with much less exposure to risks and more demanding. By the way, solar panels is an invention that's been done in space, for space exploration. That's one of the benefits of pushing the envelope.
Agree.
Now, if I may, sorry, Hendrik, we also, and I mentioned some of the scenarios earlier, but there are products you just can't make on Earth that you can make in space. And again, among the customers that we have, fiber optic, next generation electronics, drug development. Protein crystallization can be done so much more effectively. You can create new class of drugs. I think this is something that is also shaping the future. One specific sustainable example, we led Space Cargo Unlimited, a first project on agriculture and viticulture. And we grew a variety of vine plants. I'm from Bordeaux, so you expect that we see climate change every day and how it's affecting the wine industry, which is a big exporter for France and for Europe. And we saw that the vines are much more sensitive to climate change and they die. So we basically, during an 8 years program, exposed vine plants to the space environment. And by stressing them with certain protocols, in partnership with the INRAE of France and the University of Erlangen in Bavaria in Germany, we actually created a new variety of Merlot and Cabernet Sauvignon, which is 10 times more resilient to to mildew, which is a disease that grows with climate change. Without any chemicals, and we're putting it on the market this year, which actually makes us, Space Cargo Unlimited, the only company that has done an end-to-end commercial mission with a commercial output. So these vine plants, for instance, are one of the many things you can do in space for Earth.
Zooming a little bit out in the big picture, and if I think about sustainability and climate change, it's all about energy, so CO2-free energy production. And I personally see three basic technologies to provide the world at scale with CO2-free energy. And it starts with nuclear fusion, it's deep geothermy, and it's actually photovoltaic in orbit. And obviously, if you'd ask how can in-orbital production can contribute to sustainability, I'm thinking about big photovoltaic power plants in orbit, transmitting energy back to Earth, and actually protecting the Earth in two dimensions. One is by the very efficient, as you say, very efficient energy generation in orbit, way more efficient. You were saying factor 2. There are other studies, they're saying coming up to factor 7 to what you find on Earth. And in the same time, protecting the Earth from the sun emission. Yeah? So basically creating large artificial clouds through photovoltaic cells in orbit, creating energy and shielding the Earth from the sun impact, which could have enormous impact on sustainability. It's not tomorrow. It's quite some years out though, but that is where I could see huge contribution in future.
But just because it will take longer doesn't mean that we should not do it, and it will have a bigger impact. Actually.
Yeah, one thing I can add is that if you look at the benefits we can get on Earth from developing tools or anything in space, looking at this space pharma market, which we see more and more opportunities. We know people, for instance, studying and assessing the evolution of cancer cells in space. Meaning that it might be a way to find some cures that we have no chance to find on Earth. Again, maybe it's a long shot, but I think it's worth it.
We have one customer working on this, so it's really happening too. One very last thing on this topic, which I guess we're all passionate about. In space, you're exposed to danger, and there's no way you can do things without going deep into reusing everything, recycling everything. And so this bedrock, besides what can be done in space for Earth, it's also a cradle for innovation. And I mentioned we should mention microprocessors or solar panels that were invented, but also all the filtering techniques that were invented for the International Space Station. They're all useful back to Earth to diminish our footprint. So there's also that element which we should have in mind.
Yeah, starting with water. Actually, a lot of water technologies were developed for space and coming back to Earth. So next question. Do you see benefits to manufacturing on the moon? Would it reduce cost of putting material into space?
As far as Space Cargo Unlimited is concerned, we're very much using microgravity and radiation. I think that if you talk about the moon or Mars or any of the celestial bodies, it's probably raw material that is most interesting. So obviously it's more a longer term scenario, but there are a lot of interesting rare earth, cobalt and quartz and a lot of different things that are going to come harder to find on Earth that you could find in these celestial bodies. So to me, that's maybe one of the reasons that could make this relevant.
I must say, I'm not sure. I'm starting to speculate, but if I would share a hypothesis, I would be sure that the small gravity you have on Moon will already provide certain benefits to certain processes, which I don't know. And there will be other processes which will require zero gravity in orbit, and you have more advances then. So I think there will be applications which would benefit from doing it on the Moon. It's an intermediate state in comparison to what you do on Earth and what you would do in orbit. But as I say, thin knowledge, more speculation.
Honestly, I would say if it was that easy to send humans on the Moon, we would have done that again. So let's focus on what we can do under a reasonable time frame with already some great benefits, I would say.
Yeah, step by step. Okay, last question. So scaling to have so many launches, 400 to 500, the environmental impact in terms of material use, space debris, etc., it would be enormous. Will it be worth it?
I think it will definitely be worth it, but the problem addressed is a serious one. Yeah? I mean, if you think about the amount of CO2 emitted by just one launch, it's enormous. Yeah? Even a micro launcher contains some, 40, 45 tons in liquid fuel, which is going to be blown in 300 seconds. And the most stage ones are lost. Now we have all seen in a fascinating way how stage one of Starship has been first time collected for reuse. I think that is going to become the standard in the future. It will help, but it will still emit a significant amount of CO2. And obviously we have to make the trade-off and see what are going to be the mid and long-term benefits of space manufacturing in relation to what we blow out in order to bring stuff up and down. I'm personally convinced that there is a multi-times higher benefit in terms of what can we save and win in terms of sustainability in relation to the cost or to the CO2 emissions we have to accept by bringing stuff up. But it is an important consideration, and we have to think about making space logistics more sustainable than it is right now.
Yeah, actually, when you look at our own investment thesis, we are looking at sustainable aerospace and defense, and we specifically and in purpose added this sustainable word because we are specifically looking at new technologies, new companies, new founders, entrepreneurs, which can think about alternative ways in terms of propulsion or also potentially recycling what is left in space when a satellite or even a station with the ISS coming to the end in a couple of years. What will happen with all those debris and whatever remains in space? First of all, you have to think that when you look at these maps with lots of debris everywhere, it's depending on the size of the debris, it may have an impact or maybe not. But independently of that, what we've done on Earth, we definitely need to not to replicate in space. So we need to think about alternative ways, and we are already looking at a number of opportunities with alternative propulsion systems or different type of fuels and consumptions to launch. It's not an easy thing to do because you need a lot of power, of course. So we are convinced we will find ways. It may take a bit of time, but for now, what is very sure and proven is that we need to launch a lot of satellites, notably in the coming years, because it's a question of sovereignty as well. And with this defense topic coming kind of trendy in a way, we need also to be able to have ways to defend ourselves.
Yeah. No, actually, I would like to come back to will it be worth it to the intro question about who could imagine the change that the satellites would bring and all the materials, non-sustainable practice of the times. And I could not be reading your question without that. So it's just we need to find a sustainable way.
I mean, just think about what it would mean if we would detect a new forest fire at the right point of time, and we can distinguish it because of better orbit observation. I mean, that would probably compensate years of rocket launches with respect to CO2 emissions. I think it's no question, benefits are way outpacing the cost.
Exactly. Talking about Earth observation, as you said, you have a number of nanosatellites with thermal cameras which can detect a fire at the moment when it starts and in real time give signals and alarms so that it's taken care of before expanding and becoming uncontrollable. So indeed, the benefits are really important, impressive, and this is something that we need to work on, and the combination of finding ways to send things to space with a lower CO2 impact, and at the same time preventing disasters on Earth, the combination should be really beneficial.
Policing deforestation, yeah. I mean, there's so many dimensions. This is just one. This is just, observation. There are many other benefits.
I just want to say that I think Europe can play a strong role, particularly today, because I think that let's say, sustainable conscious remains strong. And I think it's an opportunity. We all here are passionate about a better Earth for humans. I think that we always say that planet is in danger. If humanity was going to the bottom of it and destroying our ecosystem, I think life will continue on Earth. I think it's humanity that is in danger. So you have to look at the benefits, cost benefits, and think what it is. And I think Europe can make a huge difference from the launch systems to the actual reusability, sustainability of our infrastructure. I mean, of course, at Space Cargo Limited, we're very obsessed by reusing everything we fly, not creating any debris. We try to choose the right launch solutions. As I said today, it's primarily SpaceX, so it is what it is. But I'm hopeful that as moving forward, Europe can make a difference by being a more sustainable space ecosystem.
We have also some pioneers working on that today. So, well, this was it for today. Thank you so much to all of you for your expertise and for this inspiring session. And thank you for all of you for being here. And I hope that you realize that it's important to keep an eye on space because it could disrupt not only your industries but also your daily lives. So, thank you so much.